So this next example is kind of a review of what we just did earlier in this lesson, except it's multiple steps. In the previous questions, you only had to do one exponent law, like multiply or divide or raise a power to a power. These ones you have to do multiple steps, and it involves negative exponents. And then the next step, we're going to look at what happens if the exponents are fractions, even positive and negative. So remember, look at the instructions. Very important to look at the very important to look at the instructions. It doesn't say to evaluate. It says simplify to a single power, and no exponents can be negative. Notice the bases in all of these are numbers, not variables. That's okay, you still do the same thing. Base stays the same when we do an exponent law. So what would this be when I multiply the two together? The whole answer, please. The what? 3? 0.3 to the negative 12 to the negative 15. Don't we add the exponents? Which means we add the exponents. You multiply the exponents when you're raising one power to another power. How do I write this without a negative exponent? You write it like that, or if your answer looked like this is correct too. Okay, the next one. We've got multiple exponent laws here. We're doing some multiplication up top, and then we're dividing. Remember, when we have a division bar, you're going to do everything up top, everything on the bottom, and divide at the end. Don't go this divide this, this divide this. Otherwise, you're going to get mixed up. So all I want to do is multiply the top. So I'm not touching the bottom. What will the top look like after I multiply those two together? One point 4 to the 7. Add the exponents. Now, last step, or next step, I should say. Divide. Base stays the same, subtract the exponents. But remember, this is 7 subtract negative 2. So it's 9, because it becomes 7 plus 2. No negative exponents, so I'm done. This is a little different, this next one, because it's got fraction exponents in, which we haven't, I mean, we've worked with fraction exponents, but not like this. What am I going to do first? I got lots of stuff going on here. What am I going to do first? We work from the inside out. So look inside. What am I going to do first inside? Ignore this. Ignore the big parentheses that says you have to do the bottom first. Because remember, with the division bar, you have to do everything up top, but there's nothing to do here. You have to do everything on the bottom, but there is something to do here. Okay, so what is 7 to the 1/3 times 7 to the 5/3? Base stays the same. What do I do with the exponents? I do not multiply. I add the exponents. So what is 1/3 plus 5/3?
6 to the 6. 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 6 to the
And I'm muting you guys. I'm muting you guys. Yeah, let me get my tongue to the top of my roof of my mouth. What's that? 6 to the third. It's not 6 to the third. Okay. So when we add them, what do we get? Don't do any reducing. 6 over 3. Now, don't reduce it yet, because I still have to subtract these two. Okay? And remember, when we add and subtract exponents, which I hope all of you know, the denominators have to be the same. And we don't combine the denominators. Okay, you managed to get through this step. Here comes the next one. I'm not touching this yet. What do I do? Yeah.
Second. And then you subtract 2 over 3 minus 6 over 3, and it's negative 4.
Don't change the positive exponents yet, because I'm not done simplifying. When I raise one power to another power, what do I do with the exponents? Guys, 3 exponent laws. When I multiply 2 powers, I add the exponents. When I divide 2 powers, I subtract the exponents. When I raise one power to another power, I multiply. So I have to multiply these 2 fractions. So I have to make 6 into a fraction. 7 to the is that simplified? Simplify this as far as you can. That's not as far as you can go. You can go further.
8.
Sorry?
Negative 8.
Negative 8. Can't have a negative exponent.
1 over 7.
So 1 over 7 to the positive 8, or 1 over 7 to the 8. That involved quite a few steps. Okay. D. I got to raise this power to another power, because we see the exponents beside each other. I got to raise this power to another power, and then I got to multiply those 2 answers. Remember, I do the exponents first. So I do the power to a power first, and the multiplication after. Base stays the same. So keep negative 3 over 2. What do I do with the exponents? To get negative 8. Times. Base stays the same, and I multiply these exponents. 6. Change your thinking, because now it's a different exponent law. Base stays the same, but what do I do with the exponents this time? Add them, and negative 8 plus 6, negative 2. But that's as a negative exponent. So what do we do? Switch what? So switch the base? Okay. Good. Okay. The next questions are very similar, but instead of numbers as bases, we're going to have variables. That's okay. Nothing changes. No rules change. gonna do A together, and then I want you to try B on your own. Or with somebody else. So, I have to multiply the x's, right? What do I do with the exponents? To get, what's 3 over 2 plus 1 over 2?
3 over 2.
3 over what?
4 over 2.
4 over 2. And then y, 2 plus negative 1. 1. Is there an easier way to say 4 over 2?
2 over 1.
Just 2. Don't leave it over 1. You can go further. And then I don't even need the 1 here. So I'm done. And I didn't have to change any negative exponents to positive. Yeah.
How's it 4?
How's it 4?
It's 5.
3 plus 2 is 5. And why are you adding 3 plus 2?
Because there's a 2 on the
There's a 2 on the y? Why are you combining x and y? I'm doing these two.
okay.
I've already forgotten. All right, give B a shot. Stating figure out B. Anybody want to tell me what it looks like when I do my division? Or just shout it out.
2.
2, 4 divided 2 is 2. A to the negative 4, B to the 1 over 3. That's correct. But now we've got a negative exponent. Remember, only the exponent and its base move. So just that moves, not the 2. The 2 is not attached to the negative 4. The negative 4 is attached to the A. So what does it look like when I move this down and make it positive?
And then 8 4.
Yes. Good. Again, we'll do C together, and then I want you to try D. Any idea how we would start? Okay.
To everything to the 1/3.
So I've got to do 8 to the 3rd. I've got to do A to the 3 to the 3rd. And I've got to do B to the 6 to the 3rd. Perhaps the trickiest part of this question is the very first part. What is 8 to the 3rd? How'd you get that? How'd you get 2?
Oh, it's enough for.
I know it's hilarious, but how'd you get it? What? It's right, but how'd you get it?
Okay. You let gaslight me.
Gaslight you?
You make it seem like I'm coming up with this.
No. You're right. So explain how you got it.
It's 2 times 2 times 2 is 8.
Because 8 to the 3rd is the same as the cube root of 8, isn't it? Because then we have to switch it to radical, which means it's 2. What's A to the 3rd? A to the 3rd to the 1/3. A to the 3, I'm going to leave it like A to the 3 over 3, but you're right, it becomes A. Because this is A to the 1st, which is just A. Remember, all these are getting multiplied. Whenever we have letters beside each other, they're getting multiplied by each other. What does this work out to? B to the
which can be easily said as b to the second.
So your answer is 2ab squared. So you got to be careful with that one. Remember, when we do fraction exponents, you got to change, you got to think of them as a radical. All right, this one you've got some work to do. You've got to divide, and then once you get a single answer, then you got to raise it to the 1/2. Remember, don't, and sometimes students will do this, don't change any negative exponents until the very end. Okay? Some students like to try and say, oh, well, I'm going to move this up here and make it positive. Technically, that's correct, but it gets very confusing. Do all your exponent laws, and then if there's any negative exponents left at the end, that's when you change them to positive. Okay. So 4, remember, a and b up top are a to the first and b to the first. So 100 divided by 25 is 4. A to the first divided a to the fifth. A to the -4. Here's the one where it's a little tricky. It's 1 subtract -1/2. Right? 1 subtract -1/2. Well, this becomes plus, so it's 1 plus 1/2. Write this as a fraction over 2. 2 over 2. Which means when we add them, we get 3 over 2.
How did you do that? Yeah. How did you change it to twos?
I just, okay, well. I'm sorry. Well, I just changed that to a fraction
Yeah, but why isn't it 1 over 1?
because I need common denominators. Okay? So this becomes 2 over 2. Plus 1 over 2. It's 3 over 2. And I still have to raise everything to the 1/2. 4 to the 1/2. Think of that as a radical. 4 to the 1/2 is the same as? Why is it 2? 2 is correct. Why is it 2?
It's like the same thing as a square root.
Right. 4 to the 1/2 is the same as square root 4. This, multiply the exponents. Well, make that over 1. What do you get? For the a's. -4 over 1 times 1 over 2. I'm doing the a right now. Now I have to multiply these exponents. Over, right. Stop throwing this around. How about this one? The b's. 3 over 4. Well, I can simplify this one all the way to what? -2. That simplified to 3 over 4. But I've got a negative exponent, so I have to make it positive, so my final answer is going to be yeah. Good. Okay. I mean, that's pretty much the most complicated you're going to see. Okay. So if you can work through that one, you're in good shape. Okay. Just got to watch your exponent laws, and don't overthink your fraction addition and subtraction and multiplication and stuff. Okay? Okay,